So today we are going to talk about congruent chords and arcs, inscribed angles, and tangent lines. So starting with congruent chords and arcs. Two chords are congruent if and only if their corresponding arcs are congruent. So if I look over here at the picture, so the chords that we are talking about here would be A, B, and C, D. So if two chords are congruent, so if A, B is congruent to C, D, then their corresponding arcs are congruent. So that would mean this arc here and this arc here. So measure of arc AB is equal to measure of arc CD. And then we also know if they are congruent, they are equidistant from the center. So starting with the two chords are congruent, so we're still talking about AB is equal to CD. Then they are equidistant from the center. So that means actually that EF right here and EG are congruent. Or they're equal. It would also mean like HF and GI, those are also congruent. Equidistant means same distance, also makes a right angle. All right, next. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So if a diameter or radius is perpendicular to a chord, so if the diameter makes a right angle with the chord, then it bisects the chord and its arc. So if EH is perpendicular to segment AB, so EH, that radius is perpendicular to the chord AB, then that means that AF is equal to FB. So those two are congruent. Which would also mean if these are the same, if chord AB and chord CD are congruent, that would mean that CG and GD are also congruent. So it bisects the chord, but it also bisects the arc. So that would also mean that measure of arc AH is equal to measure of arc HB. So that chord is, that arc is bisected. Same thing over here. And same measure of arc. All right. Next, we're going to find the indicated value. So for number 1, it says find x. So I have 2 chords here that are congruent. If these 2 chords are congruent, that means that these 2 arcs are congruent. So we can say 7x plus 24 is equal to 115. And then solve, subtract 24, so 7x is equal to 91, which makes x equals to 13. All right, number 2, we're going to find xy. So this time what's being shown is these arcs are congruent. Well, those arcs are congruent. That means that these 2 chords are congruent. So I have 9x minus 34 and 4x plus 1. We just have to set those equal to each other. I am not going to go through all the solving, but I will tell you x is 7. So if we're wanting to find xy right here, if it's 4x plus 1, so we solved x is 7. So xy would just be 4 times 7 plus 1. So 4 times 7 is 28 plus 1 is 29. All right, 3, find measure of arc RS. So if I look here, chord RS and chord PQ are congruent. So that means that these 2 arcs are congruent. So to find x, all I have to do is set these 2 equal to each other. So 11x minus 72 is equal to the 5x plus 6. And when you solve for x, you should get 13. So then to find measure of arc RS, so RS is right here. All we are going to do is just plug in 13 in for x. So 11 times 13 minus 72. And that gives me 71. And degrees, because we are talking about the measure of the arc. Remember, when you're talking about arc measures, it is degrees that you're looking for, or your units. Any questions? All right, number 4, find x. So I know that zy and xy are congruent. That means that these 2 arcs are congruent. So really several different ways that you could set it up. If this is 6x minus 20, this has to be 6x minus 20 as well. You could add all 3 of these up and set it equal to 360. Or how I'm going to do it, so I know that altogether 360, so if I do 360 minus 76, wrong number, I get 284. So that means these two arcs combined are 284. Well, if they are the same measure, divide that by 2, and we get 142. So these arcs are 142 degrees. So then, to find x, we can just say that 6x minus 20 is equal to 142. Which, when you solve, gives you x is equal to 27. All right, next 5. If MP is 5x minus 34, so here is MP right here, and PN is 2x minus 4, we want to find MP. Well, goes through the center, so if I drew it to the side, these would be diameter. It's perpendicular to the chord, so that means that MP and PN are congruent to each other. I also know that because if you see arc JK and KL, those are congruent, so these chords are congruent. So to find x, just set these equal to each other. So 5x minus 34 is equal to 2x minus 4. So when you solve all of that, you get x is 10. So we want to find MP. Well, MP is 5x minus 34. So 5 times 10 minus 34. So 5 times 10 is 50. 50 minus 34 is 16. All right, last example with congruent chords and arcs. We want to find measure of arc MP. So if I look here, these two are congruent and perpendicular. That means that these two chords are congruent, MN and PN are congruent, which means these two arcs are congruent. So all I have to do to find x is set those two arcs equal to each other. So 9x minus 43 is equal to 5x plus 33. I'm not going to show all the steps for solving, because y'all know how to solve. We do end up getting that x is 19. So we're trying to find MP. We're trying to find this measure of that arc right there. I know that these two are congruent to each other. So if I just plug in 19 for one of them, it doesn't matter. So 9 times the 19 minus 43, we get 128. So this is 128 degrees. This one should be 128 since they're congruent. Now to find our measure of arc NP, well, sum is 360. So if you just do 360 minus the 128 minus the 128, you get 104. So that means that measure of arc MP is 104 degrees. All right, moving on to inscribed angles. An inscribed angle is an angle with its vertex on the circle and two sides that are chords. So if you look here in this picture, this would be measure of angle ABC would be the inscribed angle. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So if my inscribed angle is angle ABC, where that arc, that angle intercepts the circle is your intercepted arc. So your intercepted arc here would be a arc AC. And then says the degree of the inscribed angle is equal to half the measure of its intercepted arc. So I have an equation here. If I'm trying to find the angle here, the inscribed angle, it would be half of measure of arc AC. So it'd be half of this arc. Or, let's say, what if we're trying to find the measure of arc AC? What if I have the angle, I'm trying to find this arc? We would just double measure of angle ABC. So inscribed angles. So the angle is half the arc. So if I have the arc, just half it. If we're trying to find the arc, if I have the angle, just double it. So still inscribed angles if it intercepts a diameter. So if an inscribed angle intercepts a diameter, then it is a right angle. So if I look at this picture, so diameter, BC is a diameter. The angle that intercepts the diameter is angle BAC. Just to show you that it is a right angle, well, BC cuts the circle in half, makes a semicircle. So here to here would be 180. Well, if I have the arc to find the angle, we would half it. A half of 180 is 90. So measure of angle BAC is 90. So always, if we intercept a diameter, it makes a right angle. Then we have overlapping arcs. If two inscribed angles intercept the same arc, then the angles are congruent. So I have several different angles here. If you look, we're going to use measure of angle ABD. So ABD is right here. It intercepts this arc right here, AD. The other angle that intercepts arc AD is angle ACD, so it intercepts this arc. So they both intercept the same arc, so that means that they are congruent. So measure of angle ABD is equal to measure of angle ACD. Any questions? All right, examples. We're going to find each angle or arc measure. So number 7, find measure of angle WXY. So WXY, this angle right here. I have the intercepted arc, which is 62. How would I find the measure of this angle? Yeah, just half. So half of 62 is 31. So this would be 31 degrees. All right, for 8, we want to find measure of arc DGF. So D through G to F, so that arc right there. I have this angle, DEF, which is 13 degrees. It intercepts this arc that we're trying to find. So if this is 113, how would I find the measure of the arc? What was that? Not, what did you say? Sorry. Multiply by 2. Yes. So 2 times 113 is 226. So this arc is 226 degrees. So we double it. When we have the angle, we're trying to find the arc, we double. All right, 9, measure of angle PQR. So PQR is right here. So this angle here. Well, the arc that it intercepts is right here. Well, if you see, P to R is a diameter. So remember the intercepting a diameter? If the angle intercepts a diameter, that arc makes a right angle. So measure angle PQR is 90 degrees. Measure of arc BC. So that's this arc right here. The angle I have is right here, which intercepts this arc here, AC. So I can find measure of arc AC. If the angle is 47, what do I have to do to that to find the measure of the arc? Is it half or double? Do I need to half the 47 to find arc AC or double it?
Double it.
I need to double it. So 2 times 47 is 94. So this is 94 degrees. It's not asking for arc AC, it's asking for arc BC. Well, if we see here D is the center, that makes AD, this is your diameter. So to find this, AC plus BC is equal to 180. So we just have to do 180 minus 94, which is 86. So BC is 86 degrees. We want to find measure of angle JKL. So JKL, I'm looking for this angle right here. It intercepts this arc. I do not have right now the measure of that arc, but I do have these two. I know that the whole circle is 360. So to find this arc, we would just do 360 minus 53 minus 65. And that gives me 242. So this arc is 242 degrees. But I need to find this angle here. So angle on the circle. I have the arc, so do I need a half or double this arc? Half it. So 242 divided by 2 is 121. All right, last one on this page, 12. We want to find measure of angle RST and measure of angle RUT. So first, RST is right here. It intercepts this arc right here. I do not know the measure of that arc, but what I do know, I have 75, 139, 64. I can find arc RT by adding those together and subtracting it from 360, which would then give me 82 degrees. So if that is 82 degrees, I'm trying to find this angle. So intercepts 82 degrees. What would the measure of angle RST be? $41. We would half the 82. And we also want to find RUT. So RUT is right here, where it intercepts this arc right here. Oh, that's the same arc. So 82, that means that this angle is the same as RST, which is 41 degrees. All right, next. Now we're going to do some with algebra. So 13, solve for x. So I have the measure, or I have this angle, which is 8x minus 9, and this arc, which is 158. If this is 158, to find the measure of this angle, all we have to do is half that. So 158 divided by 2 is 79. So this angle is 79 degrees. So that would mean that 8x minus 9 is equal to 79. If I add 9, this would mean 8x is equal to 88, which makes x 11. All right, 14, we're going to solve for x. So my angle here, 67, it intercepts this arc, which is 4x plus 58. So when I have the angle, you double that to find the measure of the arc. So if I double 67, we get 134. So this arc is 134 degrees. So we would just set the 4x plus 58 equal to 134, which makes x 19. All right, 15, we're going to solve for x. So x, 13x minus 1, this angle here, so it's part of this angle. Well, that angle intercepts the diameter here. So what would the measure of that angle be? The measure of this angle here be? This measure of angle WXY. 90. So 13x minus 1 is equal to 90. And then when we solve, we get x is 7. All right, 16, we want to solve for x. So this angle here. Well, this angle intercepts this arc. I don't know the measure of that arc. XW does not go through the center, so it's not a diameter. Several different ways we could actually do this. How I saw it. So I saw that this inside was a triangle. This angle intercepts this arc of 78. So if I half 78, give the measure of this angle. So 78 divided by 2 is 39. Several different ways to see this. This is just how I saw it. So I have a triangle. Some of the angles in a triangle are 180. So if we do 180 and minus the 114 minus the 39, that gives me 27. So that means that this angle here is 27. So I can say that 7x plus 6 is equal to 27, which would give me a value for x of 3. It's 17. We're going to solve for x. So this angle here is 7x minus 10. It intercepts this arc. I do not have the measure of that arc, but I do have these two. So to find this one, all three of those make a full circle. So 360 degrees minus the 92 minus the 162 gives me 106. So this arc is 106 degrees. So then to find this angle, do I have to double or half this arc? Double or half the 106 to find the angle. Yes, half it, because we have the arc to go the angle smaller, so half of 106 is 53. So this angle is 53. So we can now say that 7x minus 10 is equal to 53, which makes x 9. All right, last one of this section. We're going to solve for x. So x is on this arc right here. We do not know that QR and RS are congruent, so I can't say this is 120. The other additional information I have, this angle right here is 67. So if that's 67, I can find this arc by doubling 67, which is 134. And all three of these arcs together equal 360. So if I do 360 minus the 120 minus the 134, we get 106. So this arc is 106. So my equation to solve for x would be 5x plus 21 is equal to 106, which makes x equal to 17. Any questions? All right, now inscribed quadrilaterals. Remember, quadrilateral has 4 sides. If a quadrilateral is inscribed, that means it's just inside a circle, then the opposite angles are supplementary. So that means measure of angle A plus measure of angle C is equal to 180. Those are across from each other. And then the other angles that are across from each other is B and D. So measure of angle B plus measure of angle D is equal to 180 as well. So, for 19 and 20, the inscribed quadrilaterals. Quadrilateral, I have 4 sides inscribed inside the circle. Opposite angles are supplementary, so they add to 180. So measure of angle J. J is across from L. So those are supplementary. So 180 minus 92 would give me J, which is 88 degrees. And then for angle K, K is across from M. So those are supplementary. So 180 minus the 45 would give me 135 degrees. Right, number 20, so we want to find measure of angle P, R, and S. So if I look here, the only angle inside the quadrilateral I have is 93. I can find S though. It's across from Q is across from S, so 180 minus 93 would give me 87 degrees. So this angle is 87 degrees. So let's look at measure of angle P. So angle P would be right here. Intercepts that arc right here. I don't have the measure of that arc, but I do have these 2 arcs. So if I add all 3 of those together, equals 360. So if I do 360 minus the 126 minus 90, we get 144. So this arc is 144 degrees. Since it's an inscribed angle, vertex is on the circle. Half the measure of the arc, so half of 144 is 72. So P is 72. We got that by doing 144 divided by 2. And then R, P and R are opposite. They are supplementary. So 180 minus 72, which would make R 108. Any questions? Last page. All right, tangents. A tangent line intersects a circle at exactly 1 point, which is called the point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So over here, AP would be the radius, which just makes it perpendicular to AB. All right, so we're going to determine for 21 and 22 if AB is tangent to circle P. If AB is tangent to this circle, so here AP would be the radius, this would have to make a right angle. So in order to check, we have a right triangle, we can use Pythagorean theorem. If it is true, then it would be tangent. If it's not true, then it would not be a tangent. So your hypotenuse would be 17 here. So we can say legs 8 and 15. So 8 squared plus 15 squared is equal to 17 squared. 8 squared is 64. 15 squared is 225. And then 17 squared is 289. So if I add 64 plus 225, we get 289. So 289 is equal to 289. True. So is AB tangent? Yes, it is, since it's a true statement. We're going to do the same thing for 22. So AP is the radius. That would mean this would make a right angle. Now be careful here. This, from here to here, this is 5. Okay. It's not the whole thing, because see how here it had the whole thing like that. So here to here is 5. Well, that would mean from here to here is a radius. So if the AP is 11, that means this part is 11, which means this whole part, 5 plus 11 is 16. So the hypotenuse is 16. So your legs are the 11 and 14. So we can say 11 squared plus 14 squared is equal to 16 squared. So 11 squared is 121, 14 squared is 196, and 16 squared is 256. If I add these two together, 121 and 196, we get 317 is equal to 256. Is that true? Nope. Pythagorean theorem does not work. So no, it is not a tangent. All right, now for numbered these wrong. If JK is tangent to circle L, find X. So it's telling me that it is tangent, so that means we have a right angle right here. X is this whole thing, LK. We're still going to use Pythagorean theorem. LK is across from the right angle, so it is your hypotenuse. So we're going to say 7 squared plus 19 squared is equal to, this length is X, so X squared. So 7 squared is 49, 19 squared is 361. So if I add those together, we get 410 is equal to X squared. So to find X, we need to take the square root. So when I do that, square root of 110 is approximately 20.2. Any questions? All right, next one, we want to find x. X is just from here to here. I do know if JL is 10, from here to here is 10. I'm going to do this slightly different. I am not going to say right now that this is x plus 10. We're going to do a little bit easier method than that. I can find this whole length of KL because I already have two sides, so use Pythagorean theorem. So 10 squared plus 24 squared. I'm going to say that this all together is C. So equals to C squared. So 10 squared is 100. 24 squared is 576. So when I add these together, we get 676 is equal to C squared. Then when I take the square root of that, it actually gives me 26. So this whole thing is 26. If this here to here is 10, what would x then be? What would my length of x be? 16. All right, last little bit more tangent line properties. If two segments from the same external point are tangent to a circle, then they are congruent. So all that is saying here, so I have two tangents. They intersect here at this point. That means that these two would be congruent. AB is congruent to CB. And then the next one, if a polygon is circumscribed, so that's outside a circle, then all sides are tangent. So that would mean that DB would be equal to BE, EC with FC, and AF with AD. So looking at 24, we're going to assume that these are tangent. They touch here at A and C, tangent to that same point B. So that would mean these two are congruent. They're equal to each other. So to solve for x, 8x minus 19 is equal to the 5x plus 23. Which, when you solve, gives you value x is 14. And last one, we want to find the perimeter of the quadrilateral, so I need to add up all the sides. I already have two sides here and here, but I need to know these two sides. So we're going to have to kind of work all the way around. I'm going to start here. I know from here to here is 23. So that would mean these two are congruent. So from here to here is 23. So if this whole thing is 37.5, this here to here is 23. If I subtract 37.5 minus 23, this part would give me 14.5. So if this is 14.5, right here is 14.5. So I'm going to go ahead and kind of start writing We have 4 sides that we need to add together. This side is 37.5. Now I can find this side here, this whole side. This is 27.1, so 14.5 plus 27.1 is 41.6. So I can add that to my perimeter. And then I know this side SR, so I can add that, which is 52.5. But I need to find PS. So we're going to continue on around. I know this part is 27.1, so it is congruent to that part. So this is 27.1. So to find this part, we would just do the 52.5 minus 27.1, which gives me 25.4, which means this section here is 25.4. So to figure out what PS is, it's going to be 23 plus 25.4, which is 48.4. So we're going to add that to my perimeter, 4 sides. When I do that, we get my perimeter is 180.